Hey folks, welcome back to another video. Today we're looking at question 99, recover binary search tree. The way we'll be approaching this problem is by using in-order traversal. So the in-order traversal is when the order of the traversal is left root, right? And for a binary tree, when you actually approach it with left root right, you will get the numbers in ascending order. So it'll be 1, 2, 3 if or like 4, 5, 6. Just an example. So basically, if you have a binary tree where all of the left nodes is less than the right node, and you traverse it in the in-order traversal, which is left root right, you should get that in the ascending order, and we will use that for a benefit. So as you know, most of the binary tree questions are recursive, and this is no exception to the problem. And the way we'll be doing that is actually keeping a track of the two tree nodes that are out of order by doing in-order traversal, and we'll compare it to the previous node that we've seen. So what we need is actually like a traversal method, and it needs just one thing, right? Tree node, you just pass in root. So let's actually implement that. So it doesn't return anything, so void traverse, and then we take in tree node current, right? Once we have that, we always need to check for the base condition. So if the current node is equal to null, you just return so that we don't get any kind of exceptions, right? If it is not null, what we need to do is actually traverse on current.left, right? As in call it on the left node, right? And actually do the computation on the current node that's given to us. So how do we do that? So we actually need to check the values, right? How do we check the values? So if the current node is not equal to null, but we've already checked it here. So we actually need to check if the previous node is not equal to null. And how do we check that? So let's actually initialize them and like globally so that we can access them. So let's call it previous, and let's call it first and second. Yeah, and then if the previous node that we have seen is not equal to null, and if it is not equal to null, we can compare the value. So if previous value is greater than current dot value, what exactly does that mean? That means since we are going in ascending order, the previous value, if it is greater than the current value, that means those two nodes are out of order. And if the first node has not been assigned already, you assign first is equal to current, and you assign second to be equal to I think it's actually the other way around. So it's like previous, first is equal to previous, and the second is equal to current. So the reason why you're doing this is because if those two nodes are actually adjacent, as in like they're right next to each other, you need to be able to swap them, but you need to assign the first one only if it is null. As in like we haven't encountered another displaced node and we haven't assigned it already. That's when you actually check and assign it. If not, you assign only the second node, which is, hey, like the current value is out of place. So that's the reason why you need to assign it. And then once we are out of that loop, you assign the previous node to be equal to the current, because that's the next node that we're looking at. And then you need to call it recursively on the right node. So that'll be current.left, current.right, sorry. Okay, so this recursive method will actually go through all of the entire tree, all the nodes in the tree, and then assign the values to first and second. And the next thing that you need to do is actually swap them out. So let's create the method swap. So there will be void swap since we're not really like returning anything. So int temp would be equal to first.value. First.value would be second.value, and second.value, second.value would be equal to temp. Right. At this point, we should have replaced the two nodes that are misplaced, and the tree structure should be fixed. Awesome. So let's try compiling this and see if this is okay. Right. All right. So it's complaining that first.value is equal to null. Let's see where I could have gone wrong. So you check if current is equal to null. If it is null, you return it as is, and then you traverse current.left. If previous is not equal to null, and previous.value is greater than current.value, and if first is equal to null, sorry. If first is equal to null, as in like it hasn't been assigned, you assign it, and then you assign the second one just in case like the adjacent nodes are actually out of place. And then you assign the previous to be current. Okay, so I think that was the problem, the mistake that I made. Okay, so the first two test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n since we have to iterate through all of the nodes in the tree that's given to us. The space complexity is of 1 since we are using only constant space for our solution. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe and like the video. I'd really, really appreciate it. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks in the next video. Peace.